Okay, this is lab 3 on vectors. Okay, now before we talk about vectors, let's first define what we mean by a scalar. A scalar is the mathematical representation of a physical entity that may be characterized by magnitude only. Let me give you some examples of this. For example, temperature is a scalar, 68 degrees Fahrenheit today. Speed, charge, say the charge of an electron, mass, energy. Okay, so these are all examples of what we refer to as scalars. Now, a vector is the mathematical representation of a physical entity that may be characterized by magnitude and direction. So it has an additional property. All right. Here are some examples. Velocity, acceleration, force, electric and magnetic fields, all right. These are all examples of physical entities that have both magnitude and direction. Well, how does one designate a vector? So let's talk about the designation of a vector. All right. Now, a vector is depicted graphically by means of an arrow. All right. So, there's the arrow, and the length of the arrow indicates the magnitude of the vector. So you choose a scale and you draw a vector, you draw this arrow to the appropriate magnitude based on that scale. One designates the vector by a letter, say letter A, but with an arrow over it. In your textbooks, vectors are usually bold-faced. All right. So let's go on to the next important concept with regard to vectors, which is part of the experiment today, on the addition of vectors. All right. That is, suppose, for example, I have the following two vectors. Suppose this is x, and this is y, my Cartesian coordinate axis. And suppose I have a vector A and I have another vector B, and I want to add them up. That is, I want to determine the resultant, if you like, of the summation of A plus B. And the way one does this is the following. Let me draw it over here. Yes, x, yes, y. One draws the vector A, and then one takes the vector B, the tail of the vector B, and puts it at the head of vector A. So here is vector B, the tail of which is at the head of vector A, and then the resultant of the two, the summation of the two, is then the vector R, which goes from the tail of A to the head of B. Okay? And that gives me the sum of A plus B. Now there's an important point to note. So let me write that down here. Note, R can be obtained as the sum of A plus B, as we just saw, but that is also equivalent to the sum of B plus A. So let's see if that's the case. Let's draw the figure. Here's x, here's y. So first let's draw B. Here's B. And now I'm going to take the tail of A and put it at the head of B. That's my A. And the resultant of the two is the vector going from the tail of B to the head of A. And you can see that this is the same vector R as in the second figure above. Okay. The next point I want to make is the following. Something which I've already done implicitly, you can see that, is that one can move a vector to any position as long as one does not change its length or direction. Okay? For example, if I have a vector A, I can move it over here. This is also the vector A. Or I can move it over here. This is also a vector, the vector A. And this idea is what I've already used in the addition of the vectors above. And these types of vectors are referred to as free vectors. Okay? All right. Let's go on to a next thought. And that is the concept of components of a vector. Okay. Now, let's define what we mean by components of a vector. The components of a vector are pieces that can be used to make up the vector. So let me try to explain this idea. Okay. So suppose I have a vector A okay. Suppose I have a vector A and let's say I shine a lamp in this direction. Suppose I have a lamp, okay, and it's shining light in that direction. Then the shadow of A on the x-axis, which is the projection of the vector A on the or that shadow of the vector A on the x-axis is the vector A sub x. Okay, and let's now do the following. Let's now, this is x, and this is y. This is my vector A. Let me now let's just get this and let's put it over here. Let me now shine a lamp, put a lamp here and shine light in this direction. Let's say this is the lamp. Then the shadow of the vector A on the y-axis, which is the projection of the vector A onto the y-axis, is then this vector A sub y. All right? And now you can see from what we said in the previous page about the addition of vectors. I'm going to use that idea. And you can see that, and let me do it over here. This is x, this is y. You can see that if I have this vector A sub x, and I add the vector A sub y, which is this vector A sub y, right? I put the tail of A sub y at the head of A sub x, and then the vector A is the vector from the tail of A to the head, A sub x, to the head of A sub y. And so I can say the following, that A equals A sub x plus A sub y. Okay, so these A sub x and A sub y are the components, the pieces which make up A. All right? Now, let's call this the angle theta. All right? That defines the direction, that defines more precisely the direction of the vector A. All right? So now, I want to determine the magnitude of the vector A sub x. The magnitude of the vector A sub x, which I will call simply A sub x without the arrow, is equal to, and one looks at the triangle, the right triangle, which is formed over here, okay, that right triangle, A sub x is equal to A cosine theta. Similarly, the magnitude of A sub y, which is A sub y, is A sine theta. Okay? The magnitude of the vector A, the magnitude of the vector A, which I will designate as simply A, is then obtained from the Pythagorean theorem as the square root of a sub x squared plus a sub y squared, okay, from the right triangle. All right, the sides being a sub x, a sub y, and a. Now let's divide a sub y by a sub x. This is equal to a sine theta over a cosine theta. All right, the a's cancel out, and so one has sine theta over cosine theta, which is tan theta. And what this means, okay, what this means is that theta then is the inverse tan ay over ax. So if you know ay and ax, you can find the angle theta. If you know ax and ay, you know the magnitude of the vector A. So knowing the components, you can determine the vector, okay, which is the next part of the experiment, which is about adding vectors using components. Okay. Now let's take an example of what I'm talking about. Suppose I have my Cartesian coordinates. Suppose I have a vector A and to it I add the vector B. Okay. Then I know that the sum of the two is the vector C, okay, is the vector C, which goes from the tail of A to the head of B. And now let me break up the vectors A and B into its components. So here's A sub y, and here's the vector A sub x. Similarly, here is the vector, here's the vector B sub x, and here's the vector B sub y. Okay, I've broken up the vectors A and B into its x and y components. And now let's look at the following figure. Let's look at the following figure. Here's my vector A, Here's vector B. Here's the sum, which is the vector C. And now let's draw the components of the vector C. Well, this is the component C sub y, and this is the component C sub x. And you can see immediately that in terms of magnitudes, C sub x is A sub x plus A sub y, and C sub y is A sub y, the y component. Oh, this should be a B, sorry. This is B sub y. Sorry. Plus B sub x, and C sub y is A sub y plus B sub y. Okay, and consequently, this statement is equivalent. These statements are equivalent to saying C equals A plus B. Vectors A plus B. All right. One final thought, and that's the following. The negative of a vector, okay? The negative of a vector is represented by an arrow of the same length as the original vector, comma, but pointing in the opposite direction. Okay, that is equivalently by multiplying a vector by -1 reverses the direction of the vector. Okay, so let me underline that. Reverses the direction of the vector. So if I have a vector A, if this is the vector A, then this is the vector minus A. All right? And so you can say, therefore, A minus A, which is equivalent to saying A, and then you add minus A, and of course one must obtain 0. Okay? So let me give you an example of this. Suppose I have suppose this is x, this is y. Suppose I have a vector A and I have the vector B. All right. The vector minus B is then this vector. Okay, this is minus B. And so suppose I want to determine the vector D, which is equal to A minus B. How do I do that? What I do is the following. There's my x-axis and y-axis, and let's first draw the vector A, and to it I now add the vector minus B. So I'm going to add the vector minus B. This is the vector minus B. So I take the tail of minus B and put it at the head of A, and then the vector D, which is the sum of vectors A and minus B, then that vector is from the tail of A to the head of minus B. Okay? In terms of components, one has the following. One says dx is ax minus bx, and dy is ay minus by. All right? And so here you now understand how to add and subtract vectors, and this last thought is a critical element of one of the experiments that you're going to perform during the lab. Okay.